So again, I appreciate you folks coming out for REDARC's 12-volt dual battery, auxiliary battery class. I'm Jason Groom. I am the North American Sales Director here at REDARC. And today, some things might be a little rudimentary. I'm not sure where you're all at in your journey on this. So some things you may already know, some might be new to you. So we'll kind of start at the beginning and work our way up. How many of you folks have a 12-volt system on your vehicle currently? And how many of you folks had dual batteries on that? So probably all you folks had the 12-volt system on your vehicle, because that would be like the normal start battery. So we all started out with just one battery in our vehicle, and we'd run lights on it or we'd run the stereo, and inevitably we wouldn't be able to start that vehicle when we got back in the car and we wanted to leave. So we thought, okay, let's take two batteries. Two's better than one. We'll take two batteries, we'll put them in the vehicle, and we'll run them parallel. Parallel meaning you're taking the batteries positive to positive, negative to negative. So you can put multiple batteries together. And what that will do is that will increase the amp. So if you have a 40 amp and another 40 amp battery, you will have 80 amps of power on a 12 volt. But we still didn't have a way of isolating the start battery. We just had them together. So inevitably what would happen again? You'd have a flat battery, you'd leave the stereo on longer, or you'd leave the lights on longer, and you'd run into a problem. So thus we needed a way to isolate that start battery from your secondary or auxiliary battery, which is up in the corner of this Toyota Tacoma there. At first they were mechanical switches. You might have seen them on old RVs, or on if you had a runabout boat, it would have a battery switch and it would say off, one, both, two. And inevitably, your kid would leave it on both when you were at the sandbar or when you were parked, and you'd have that same problem again. You'd have two batteries tied together that you'd run dry from running whatever accessories you were gonna run. And need's still there for power, but we have to isolate that start battery. So what came along after that was what REDARC calls, and there'll be a little REDARC slant to this since I am an employee of the REDARC Corporation here, was smart battery isolators, electronic isolators that will go ahead and they will isolate the start battery, and they will allow power to pass through to charge your auxiliary battery. And that's a good setup. So what something like this does is it looks for 13.2 volts coming out of the start battery. So generally, even if the vehicle's not running, if there's more than 13.2 volts, this will close the solenoid, which is basically joining those batteries together. It's completing the circuit, and it will allow alternator power to pass through not only from to the start battery, but then over here to the auxiliary battery as well. So now I'm charging this battery. When I start putting my loads on, let's say I have lights, a refrigerator, and the refrigerator I think is the game changer. I think that's one of the biggest things that folks are putting on there. You know, once you don't have a soggy sandwich, and you know everything's staying cold all weekend, that's one of the biggest reasons people are doing these auxiliary systems. So as the fridge goes and the lights go, when we get down to 12.7 volts, it's going to say, whoa, I don't want to kill my start battery. So I'm going to go ahead and open the circuit, meaning that the two batteries are no longer joined together, and this will continue to drain from whatever load you have going, whether that is the refrigerator, lights, or whatever they may be. But this is protected. So we never can run into the chance, as long as we have all of our loads that are running hooked to our auxiliary battery, we'll never run into the chance of killing our start battery and not being able to start. So this sounds pretty neat. I mean, this is only like a $100 part. What are the challenges on this? Well, in this type of technology, there's a couple of challenges that these have that I'll get into right now. One is alternators are not really designed to charge a flat battery from all the way down to all the way back charged. They just dump power. Normally what your alternator is doing, it comes on when your vehicle starts, and then it just tops your battery back off, and your battery just sits there and it's kind of just maintaining it with the regulator. But when it has a battery that has been run down, that alternator is just going to allow power to just start cruising through that solenoid and really filling that up quickly. So what does that do? It's not the best thing on the battery as far as longevity goes to keep cycling it like that. but it's also going to charge it too quickly. So when you're charging this thing too quickly, kind of think of like a pitcher of beer. You can take a glass and you can dump that beer into it through the pitcher and it foams up and your glass looks like it's full, but in reality, it's not a good full beer. It's gonna sit there and kind of work its way down. Same thing with alternator charging. It's gonna charge it super quick. The battery doesn't like that. There's manufacturer specifications on how quickly to charge a battery. And then it's not gonna have a nice full charge the next time you're at camp. It's gonna wear down quicker from the loads faster than it did before. So that's one of the challenges. The second challenge on this would be they have to be like batteries. So if this is a lead acid, which is the standard battery that's in a vehicle, that should be a lead acid as well. So the like batteries, you have like charging parameters on them. If you have an AGM, that would want to be an AGM. You can't put a lithium battery in there because the lithium won't charge correctly going through this solenoid. So that would be a second challenge of this type of technology, the smart battery isolators. The third challenge, which is one that a lot of folks have on their vehicles, if you have a vehicle that's from mid-2000 or newer, there's a good chance that it has a smart alternator on it. So they'll call them a smart alternator. It might be a temperature alternator. Basically what it's doing is when the vehicle is driving, it might drop the voltage down to 12.5 to save just a tiny bit of fuel economy. So question, does anybody remember when this thing opens up, what voltage? 12.7, that man gets a hat. So at 12.7, this would open up and you would no longer be charging that auxiliary battery. So you could be driving for hours and not charge that auxiliary battery, and you get to camp and you're like, what's wrong with that REDARC product? No, the REDARC product was doing its job. It was just not the right product for that particular application. So the next technology that came into play that is a smart charger or a DC to DC charger. We call ours the BCDC series. So a smart charger is gonna act just like if you had your battery at home and you had a smart charger in the garage and you plug it in and it goes through different stages of charging to give it a really nice charge. So now you've got that cup and you've got the pitcher tilted over and you've got the cup tilted right and you're gonna give it a smart charge. You're gonna do a boost to start off the process. You're gonna do an absorption and then you're gonna float that battery. So this is no longer taking the power and just allowing alternator power to dump through. This is taking that power and it's changing it into either up or down, whatever voltage is going into it. It can operate from 10 volts to 32 volts. It will take that, run the algorithms to properly charge the secondary battery. So another thing that comes into play on this is now I can use any battery profile I want. So I could use lead acid, I could use AGM, I could use gel, or I could use lithium. So that allows me a lot of different applications that I can use on there. So what about the battery? What's the difference? Why would I use one over the other? Lead acid has been around forever. Lead acid is the standard starting battery, the least expensive battery out there. And as I talk about batteries and I talk about loads from this point forward, I'm going to talk about amps or amp hours, you know, how many amps something can give off in an hour or how many amps it has available to give off in an hour. So in a lead acid or an AGM, which is basically a lead acid, same with the gel, but different material and packing, and doesn't, AGM and gel aren't going to bleed off hydrogen gas as often as this lead acid. You definitely wouldn't want that lead acid battery in your sleeping quarters. And really, gel and AGM's a little iffy on that too. If it's charging too fast, it might have to vent a little. Lithium does not. The other thing that happens is when you're running a system, the amp hours, as I mentioned, they become very important. Everything has amp hours. So the lights on top of this truck, each one might take 3 amps. So if this is a 60 amp battery right here, let's say I have 30 amps worth of loads running right now. How long do you think I would have that I could run it? If it was lithium, I'd have 2 hours. So that's one of the other differences on the batteries. So the lead acid, AGM, and the gel, you really can only use about half. The newer batteries say you can get like 40 or like 60% or maybe even 65 of usage out of it. So if I had a 100 amp AGM battery or gel battery, I really should only be using about 60 amps of that before I need to charge it up. If I have a lithium battery, I can pretty much use all 100 amp hours of that. So that's a really big selling point for the lithium batteries. And so how do we put together a system? You know, this is great. We've got our batteries. We know, okay, I might spend a little more for lithium, or I might do AGM, or I might do gel, and I have my power. What do I do? What charger do I need? Because I have this in a 25 amp, I have this in a 40 amp, I have it in a 50 amp charger. What we always say when creating a system is start with what loads you're gonna have on it. So I have a refrigerator in this truck. When that refrigerator cycles, it cycles at about 4.5 amps. When it's sitting at idle, it's really drawing nothing. It might sit at 0.2 amps. So let's average it. You know, I like easy math, so I'll just say it's about 2.5 or whatever, and I have another light that's 2.5. Let's put that at 5. So let's start adding everything up. And what we come up with, let's say I come up with 50 amps if I turn everything on for 1 hour. Everything that I'm planning on running here, I turn it on for an hour, it's 50 amps. That, if you're doing a lithium battery, that might be a good starting point for your system. Either a 50 amp or double it for a couple hours, or 100 amp. If you're doing AGM or gel or a deep cycle style lead acid battery, then you might figure you needed 100 amp because you're only going to use about half of that. So that's, you know, how you start the system. So now I'm going, okay, let's keep the math a little simple. I've got a 100 amp lithium battery in the back. That's what I'm using, right? So now I'm like, okay, what do I need to charge it? Do I use the 25? Do I use the 40 or the 50 amp DC to DC charger? What do I need on that? So the battery companies will have on there what their recommended charging percent is. A lot of times, to err on the side of safety, you might say like 25% charging rate, which 100 amp hour would be a 25 amp charger, which is why this is one of our #1 selling BCDCs is our 1225D. You can get away, a lot of the battery companies, the batteries are getting better every year, these lithiums. So a lot of them now will say 40%. So we get a lot of people that safely put a 40 amp in there to get quicker charging. So if it was a 100 amp hour battery, and let's say I drained it all the way down, and this is a 25 amp charger, I might even be able to do this math. How many hours would it take to fully charge that battery at 25 amp hours? The man in the back said 4. So yes, it'd take about 4 hours. So you can see that if you were able to safely put a 40 amp in there, it would charge that quicker, like 2.5 hours or something like that. Don't quote me on all my math, because sometimes I run a little bit off on the math here. But so I have this going to the positive of my start battery. I have this going to the positive of my auxiliary battery, this brown wire here. So that takes care of those two guys. This is going to the positive on my MPPT solar regulator, which is coming out of the front of the vehicle here. And then on that parallel, on that Anderson plug, the negative, just to let you know, goes to a chassis ground. Everything in this equation all goes back to the same chassis ground, whether it's in the back of the truck for power sourcing, something like lights or refrigerator, front of truck, whatever, it all goes to a common chassis ground. With the smart alternator, so that would be, this is the ground. With the smart alternator, this blue wire is what is utilized to find a signal that from the vehicle that it's running. It could be your entertainment center or anything that comes on when the vehicle starts running. But the configuration, and I hope this answers the question, the configuration for the programming comes from these two wires here, because that's setting the battery and that's setting what the charging parameters are. So don't quote me on this 100%. When they're both off, it's lead acid, ground one, it's gel, ground the other, it's AGM, something along those lines. Put them together and it's for the lithium profile. And that's it, that's your complete setup. It's something a do-it-yourselfer could very easily do. So that's where your charging is on this. Now let's talk about, hey, I want to maintain, I drove out there and I'm at my campsite. I don't want to start my vehicle. Let's bring solar into the equation. So solar is really the game changer for being able to keep that fridge running indefinitely while you're out there. So our BCDCs have the MPPT, maximum power point tracking solar regulator, already built in. So not only do you have it charging while you're driving, now when you go and you park the vehicle, we have a little Anderson connector up here that goes to that yellow wire. Our solar panel's set up and it's actually charging via solar right now. So how much solar do I need? Okay, we kind of figured out how much battery we need because we went off of the load. How much solar do I need? Kind of the same idea. You're going off of, first of all, what charger do you have, what your loads are, how quickly you want to charge them. A good rule of thumb with solar is for about every 100 watts of solar panel that you have, in bright sun, you're going to get somewhere in the neighborhood of 5 to 6 amps of charging. So if I was using a 25 amp charger, I probably wouldn't really want to go over 500 watts of solar, which that's a lot of solar, but it's not going to go through the charger anymore. If on a bright sunny day, I might be passing that 25 amp mark. But that's really the equation you start using on that. And if you have a wattage, you can divide it by the volts to get the amps. I like working in amps. It's just easier for me. So then what about inverters? You know, wow, gosh, we have batteries to think about. We have chargers to think about. We have solar to think about. Now we have power inverters to convert from 12 volts to our 110 volt. So we can run a coffee maker, a hair dryer, a heating plate, or anything like that. Remember, keep that in mind when you are tallying up all the things you may run. Once you bring an inverter into the mix, you usually start using a lot of power. If you look on the bottom of a coffee maker, it'll say 5 amps, roughly. That's 5 amps AC. If you want to take that AC and change it over to our DC amps, multiply it by 10. So now that little harmless coffee maker is using 50 amp. So on our 100 amp scenario with battery, that coffee maker will kill that battery in 2 hours. So when you're bringing in things like heating elements, electric heaters, cooking surfaces, that's when you really start burning a lot of amps, and it's something to consider. So that's kind of it for just the basic side of the 12 volt. I went through things pretty quickly. Does anyone have any questions for me? So the question is, you know, if you have 2 running batteries, for start batteries in the diesel, and then you have 2 auxiliaries. So what would happen is if we were using a BCDC style system on there, the solar would be going through to the auxiliary batteries to charge it. And then we could take something like a dual sensing smart battery isolator. And what would happen is instead of flowing from the start battery back over to the auxiliaries, it would sense 13.2 volts or higher on your auxiliary batteries that your solar is charging, and it would close the circuit to then trickle that back up to the front batteries. Well, your start batteries are already in parallel. So they're already in parallel, so that really counts as one battery. And what that's doing is parallel, as we recall, will double the amperage, but keep the voltage. And that's positive to positive and negative to negative. Series, which would be a positive to a negative, and then going out to your load on one side and your input on the other, would double your voltage but keep the same amperage. So people use that for, sometimes you hear people using golf cart batteries, 6 volt golf cart batteries. They really take a nice deep charge, and they'll run them in series to get the 12 volt system. So your alternator, that was a great lead in, thank you. Your alternator uses about half of its power for running the vehicle loads. You know, if all your vehicle loads are on, generally it's going to be sitting at about half of the power. The rating on that alternator in amps will be you can either get it by looking on forums and talking with people, going to an auto parts store online and looking at the alternator for that vehicle, and it will usually tell you the amps in the description. So you generally have about the other half of amperage to play with. But just like everything, you don't want to, going 100% on anything is usually not going to end well in the long term. It's hard on the equipment and whatnot. So in this scenario, if I had a 100 amp alternator, you'd figure about 50 would be going into that. Let's say it's more likely like a 200, closer. I think it's 150. I'm getting closer to the limits of that. So I could have 75 amps that I can play around with. Well, I've got 25 here and I have a 30 system in the back to show our big Manager 30 Red Vision kit, which I can also show you folks if you want to see back there. So generally I'm somewhere in the neighborhood of 55 amps if everything's going. I have about 75 amps to play with, so you can use about half of that alternator for charging. Honestly, if you need extra help on any of this stuff, we have converters that are on our website, redarcelectronics.com. They'll tell you what size inverter you might need. We now have inverters. We have 400 watt, we have 1,000, 1,500 watt, 2,000, and 3,000 watt inverters. Calculators will show you just, hey, I want to run these appliances. This size inverter will do it. There's also calculators on our website to go over things like I just went over. What size charger do I need? What system do I need? So all that's at redarcelectronics.com. So appreciate your guys' time. Thank you very much.